Alrighty, folks, here we are with the grand finale of chapter 4. Looks like I have a little residual action from this. Okay, so the last part of chapter 4 is the quadratic formula. We are continuing to just find where our parabolas are crossing the x-axis. Keep in mind they can cross 2 times. That's why we get 2 answers from the plus minus. Sometimes they're just kind of sitting there and they just have one real solution. And then sometimes they're what I call floaters. And so they don't cross the x-axis at all. And that's when you're going to get those numbers that are imaginary or solutions that are imaginary that we talked about. So I believe everyone has worked with this before. The A, the B, and the C come from back when we were doing the different forms. We had standard form, and that A, B, and C come from that. So this is the one that you use when you have standard form. We kind of looked at vertex form. You would use the square root to solve. Here you're best using quadratic if it doesn't factor. So first thing you need to do is make sure that it's equal to 0. So you need to set or get that equal to 0 before you can start. So in this first one, I have a 2 over here, and I need to minus that over. And so now I've got this. And so I am going to set that equal to 0. And that means my A is 1 in front of the x squared, my B is 3 in front of the plane x, and my C is negative 2. So I just start plugging it in. X equals the opposite of my B plus or minus the square root of B squared minus 4 times A times C. You include that negative sign all over 2 times A. So I always do this part first on my calculator, and I just find out what that number is going to be. And so otherwise it's too much to get in my calculator. If I do that part first, you're going to end up with a 17. I see that I wrote A on the bottom. Sorry, you guys. I want to put the A value in there, which was a 1. So I'll put that in there. And then the bottom 2 times 1 becomes a 2. So again, like I talked about with the eyes, unless you can take something out of all 3 corners, you really can't take anything out. So nothing goes into those. And you would only be able to look at the number in front, which is a 1. But nothing divides into 1 and 3 and 2. So your final answer is just negative 3 plus or minus the square root of 17 all over 2. So that formula or that format, that look to your answer is actually going to happen a lot. So don't panic. All right, this one's equal to 0 already. A in front of x squared is 1. B is negative 4. C is 5. So if I start my process with the opposite of B, the opposite of a negative 4 is going to be a positive 4. Plus or minus, and then my square root. Now be careful here. When you square B, you got to use parentheses if it's negative. I didn't really use them here. I could. If you use them every time, you'll never go wrong. But if you don't use them with the negative, your calculator is going to give you the wrong thing because it thinks you want it to take the opposite of 4 squared and it will get this. That's not what you want. You want it to actually square the entire thing so that the negative disappears, but it will only do that if you put those parentheses. So do that. And then minus 4, just because there's a 4 in my formula. My A value is 1 and my C value is 5 all over 2 times my A value. Again, do what's under the square root first. Do this whole thing on your calculator. You're going to get 16 minus 20. So that turns into negative 4 and then over 2 times 1, which is 2. So on this previous problem, there was nothing we could do with this root 17 because it doesn't simplify or contain any perfect squares. But in this next problem, we can do something with this. A couple things, actually. So if you kind of think of this as its own little problem from the previous homework we've been doing, this would be the square root of 4, but it also has a negative. So the 4 would come out as a 2, and that negative 1 would come out as an I. So then this becomes 4 plus or minus 2i from here over 2. And now this can reduce because, again, if you think of it as a big triangle, all of these can reduce by 2. So you do that. So 4 divided by 2 is 2. 2i divided by 2 is just I, and then on the bottom, that 2 divided by 2 turns into a 1, so I don't need to write it. Here I have, it's already equal to 0, so a is the 1 in front of x squared, b is the negative 6 in front of x, and c is the 12. So again, I'm going to take the opposite of b, but the opposite of a negative 6 is positive 6, plus or minus the square root, and I'm going to try to get this thing out of the way. I never know what I'm doing, how to get that to move. Okay, fine. You know what? I won't. So where was I? Okay, I need to square the b. It's negative, so it's going in parentheses, minus 4 times a times c all over 2 times a. This looks like a b, but it's really a 6. All right, so again, do the part under your calculator first. This whole thing right here. I get out my calculator, I type that all in, and I end up with 6 plus or minus the square root of negative 12. So I'm going to have an I in this problem as well. So again, it might be easier to take this negative 12 root over here and work on it as if it was a previous day homework. I would have 4, which goes into there. I can get 4 times 3 off my blue card, but then I also have the negative. So the 4 will come out as a 2. The negative 1 will come out as an I, and then square root 3. So this is what goes where this square root of negative 12 was. So I end up with 6 plus or minus the 2i root 3 that I just got all over 2. But again, looking at the numbers out front, in a triangle, 2 comes out of all of those. So 6 divided by 2 is 3. 2i divided by 2 is 1i. The root 3 is just still chilling there because it doesn't have, it can't divide by a real number. And then on the bottom, 2 divided by 2 is just 1. And if you have a 1 on the bottom, you don't have to write it. So the reducing part is really just looking at the numbers and seeing if you can just reduce it out by some value. Okay, so back in the day when we first started chapter 4 1,000 years ago, we were talking about the big picture. Height of an object after t seconds. So keep in mind when you throw something up in the air, it comes back down, right? So this is the formula they want us to use. You notice it's in standard form. The key features we have found in the past were the vertex. If you kind of remember this, we would figure out like how far out was it? That was the x part of the vertex. How high up was it? That was the y part of the vertex. If you remember from when we were back in my class, you have your orange chart. But when we did these to find the x, we would take the opposite of b over 2a, which, by the way, is kind of this part. And that would give us our x coordinate for the vertex. But then the y part we would find by plugging that in. So we would plug in this value for x into the original equation. And I'm telling you that because you're going to need to redo that here. We're kind of putting all the concepts together. So the height in feet of a baseball t seconds after it hits is given by this specific function. Maximum height. Okay, in my picture, the maximum height is going to be this y part of the vertex. That's what it's asking about. But in order for me to find the y part of the vertex, I need to find the x part of the vertex. So I go back to that beginning part of the chapter and I think, okay, to get the x part, I take the, well, first let's find our a, b, and c. A is negative 16, b is 96, and then c is 3. So when I go back to get the opposite of my b over 2 times a, I have this. Keeping in mind, I want to divide by this whole thing, so that's a 32 on the bottom. The negatives cancel, and I get 3. So the x part of the vertex is 3, which is just telling you that after 3 seconds, it is hitting its highest point. That's not actually what it's asking. It doesn't say when does it happen. It actually is like find that height, which is going to be the v sub y. And I find it by taking my equation and plugging in the time. I just found out that it happens at 2 seconds. But that's the X part of my vertex. So I plug it in, I use my calculator, and I get 147 feet. That's how high it is at that moment. So again, maximum height is always going to mean the Y part of my vertex. So I have to think back to the beginning of the chapter and review how to do that. This is something we didn't know how to do at the beginning of the chapter. It says, when would the ball hit the ground? So it's interested in this spot over here. This one didn't start on the ground because the kid threw it. And if you remember from the beginning of the chapter, this is my Y-intercept. So it started 3 feet off the ground. It got thrown up and it's landing here. So it's hit by the ball, I should say. So he hits it with a bat, it goes up, comes down, and then this is the actual question they're asking is when would it hit the ball, meaning how far forward, how much time has passed. So when means we're looking for a t, which is in the x spot of our equation. So those are like this point back here, which we won't be interested in because it happened before he hit it. But this one we'll be interested in, and we find those. Like this ground represents the x-axis and our parabola is crossing it in those two places. So we are looking for the zeros, the solutions, the x-intercepts, whatever you want to call them, it doesn't matter. We're always looking for the same thing. And to do that, I would normally factor, but I am absolutely not able to factor this. So I'm going to have to use my A, B, and C and my calculator to do the quadratic formula. So my x's will be the opposite of my b plus or minus the square root of my b squared. I can use parentheses. They're not essential because it's not negative. And then the formula says to take away 4 times a times c all over 2 times a. Whew, that's a lot. So bust out your calculator and type this whole thing in. And you should get 9,408. And then on the bottom, 2 times negative 16 is negative 32. All right, so of course I didn't leave myself enough room. Let's hop down here. So I have 2 scenarios to calculate because I have 2 places that it would have hit the ground. One of them is behind the hitter, so actually that one won't matter, so we won't use this one. So I got to figure out which one's which. The way I get 2 answers is from this thing. I'm going to separate it into the one where you add it to the square root of 9408 and then take that answer and divide by 32. You have to do this whole thing first. And so when I do that on my calculator, I get a negative number. I don't have my calculator right here, so I don't know that number. But because it's negative, it's before it was hit, and so this one doesn't make any sense. So this is going to be the one we're not using. But if I do that negative 96 minus, because of the plus minus sign, 9408 square root, and then after I get that whole answer, divide by negative 32, I get 6.03 seconds. And if I have 6.03 seconds, then that is this one over here. So it was in the air that long. Now you'll notice before we used to just double this, but because it didn't start on the ground, that's not perfectly accurate. It's really close, but it's not perfectly accurate. So now we're using that quadratic formula to find the exact spots. So hopefully that helps. That is the end of the chapter. The test is going to go from solving by factoring, so 4-3, 4-4, and then 4-5 where we did solving with square roots and simplifying those, 4-6 where we did imaginary numbers and complex numbers, and then now 4-8. We did not do a 4-7, and so that won't be on there. Hope this helps. Bye, guys.